Hello there and welcome to the Sleepless Science. I'm so glad you're here tonight, I truly am, because tonight's journey is going to be something especially beautiful. It's one of those moments in science where the explanation is as lovely as the experience itself. Something we've all seen, some of us have tried to chase, many of us have tried to photograph, and yet most of us have never fully understood. Tonight we're going to follow sunlight through the rain. We're going to step quietly into the physics of wonder and trace the path that leads from invisible white light to the soft, radiant arc of a rainbow. You may have seen one just this week, or maybe not for years. Maybe you caught a glimpse of a faint bow peeking out from behind passing clouds after a summer downpour, or spotted one shimmering quietly over the spray of a fountain. Maybe it arched bold and brilliant across the sky while you sat still in your car engine off windshield. Dripping time slowed for just a moment, and for that moment you weren't thinking about traffic or errands or phones, you were just looking up. And that's the thing about rainbows, they're not just colour and shape, they're atmosphere in every sense of the word. They hush the world around you. They invite you to pause and to wonder, and to notice how light can whisper across water, and become visible in the most unexpected ways. So wherever you are now, maybe curled up in bed or lying on a couch with the lights dimmed, I want you to get comfortable. Maybe close your eyes, let your shoulders drop just a little, and if your breath wants to slow down, let it. If your thoughts want to quiet, let them be like mist settling on a lake tonight. We're going to move slowly, not because the science is difficult, but because it deserves to be savoured like a favourite story told under the stars. Before we start, though, just a quick, gentle reminder. Everything we talk about tonight is for curiosity and calm, it's not medical advice. So if you have any concerns, especially about your vision, or your eyes, or anything else that's been bothering you lately, please speak to someone who's trained to help you with that. Someone who can look directly and lovingly at your particular needs tonight, though you don't need to do anything but rest and let this story carry you. Now let's begin not with the rainbow itself, but with its composer, the sun, not the sun as it is at noon burning hot overhead, but the sun as it's just starting to dip low, casting soft golden beams across rooftops and treetops. The sun as it looks when the world turns amber and long shadows stretch across the sidewalk. The sun that feels a little quieter. Sunlight seems simple. It lights up our days, it warms our skin, it pours through windows and fills rooms with brightness. But sunlight isn't just one thing. It's many things woven together. When you look at sunlight, you're seeing something that seems white or pale yellow, depending on the time of day. But in truth, it's a symphony of colours all travelling together in harmony. What we call white light is really the blending of all visible wavelengths of light, from the deep reds through oranges, yellows, greens, blues, all the way to indigo and violet. And each of these colours has its own personality, so to speak, its own wavelength. Red light has long, slow waves, soft rolling hills across the electromagnetic sea, while violet has tight, short, quick ripples, more like fine brushstrokes or violin strings. Each wavelength behaves a little differently when it meets the world around it, and that's where things get interesting. Because light doesn't just move in straight lines, it interacts, it shifts, it dances, and when it moves from one medium to another, say from air into water, it changes speed. And when it changes speed, it changes direction, a process known as refraction. Now this is where the magic of the rainbow truly begins. Imagine a single drop of rain suspended in the air. Maybe it's falling. Maybe it's drifting on the breeze. That drop is round, smooth, nearly perfect, and light from the sun hits it. Most of that light passes through and continues on, but some of the light enters the droplet, bends as it slows, then hits the back of the droplet, reflects off the inner surface, and bends again as it exits back into the air. This journey, this path inside the droplet, splits the light into its constituent colours, because each wavelength refracts just a little differently. Red bends less, violet bends more. This separation is tiny inside the droplet, but it's just enough to begin the birth of a rainbow. And remember, that's just one droplet, one moment, one tiny glass globe in the sky. Now multiply that by millions, every droplet refracting, refracting again, each acting like a little prism, and together they create something much larger, something arching and luminous, something quietly breathtaking. And here's something beautiful to consider. A rainbow doesn't exist as a fixed object in the sky. It's not a location you can approach, or a structure you can find. It exists only in relation to you, your eyes, the position of the sun behind you, and the raindrops in front of you. You see, a rainbow is not painted onto the clouds. It is not hung in the sky like a banner. Instead, it is a precise consequence of geometry and light. Your eyes only see the rainbow when sunlight enters a droplet at just the right angle, reflects inside it, and exits again on a path that leads directly to you for red light. That angle is about 42 degrees from the direction opposite the sun for violet. It's a bit narrower around 40 degrees. All the other colours fall in between, which is why they stack in that familiar sequence: red on the outside, violet on the inside. The shape that forms from all these perfectly aligned droplets is actually a circle centred on the shadow of your head. If you've ever flown in a plane and seen a rainbow far below, you may have seen the full circle, not just the arc we observe from the ground. The rest is simply hidden from view, cut off by the horizon. And what's more, no two people see the same rainbow. Even if you're standing side by side, the droplets sending light to your eyes are different from the ones sending light to theirs. So the rainbow that reaches you is uniquely yours, shaped by your perspective and position in that moment. Isn't that quietly profound? Something so seemingly universal actually exists only for you, a personal arc of colour spun out of light and water and chance. So let's slow things down even more and imagine ourselves following a single beam of sunlight, a single strand of white light travelling all the way from the sun through space, through Earth's atmosphere, through drifting clouds until it reaches a droplet just hovering in the air. We enter that droplet alongside the light. We watch as it slows, refracts, bends, shifts, red curves, just a little, violet curves more. The light reaches the back of the droplet and reflects, bouncing like a whisper off glass. It travels back toward the front and exits, bending again, and now its colours are more distinct, spread out just enough to catch the eye if the angle is just right. And now our beam leaves the droplet and heads directly for your eye, and you alone among millions of people are standing in exactly the right place, at exactly the right time, with the sun behind you, and the rain ahead, and the world quiet enough that you notice it. You don't have to do anything else but look, and there it is. Now imagine this happening not just once but countless times. Droplets all over the sky, each catching and casting their own narrow beam of coloured light. Only a few reach you, only a few form the angles necessary to create that band across your view, but together they are enough. They are more than enough. And that's the first rainbow, the primary bow, wide and brilliant with red on the top and violet at the bottom. It's the one we think of when we hear the word rainbow. And it's all made from just one reflection. Inside each raindrop, just one little bounce and two gentle bends, but sometimes there's more. If the light reflects twice inside the drop, it takes a longer path, exits at a different angle, and forms a second larger rainbow outside the first one. This is the secondary rainbow. It's fainter, and its colours are reversed. Violet on the outside, red on the inside, a delicate echo of the first, and between the two rainbows is a region that appears slightly darker. This shadowy space is called Alexander's Band, named after the ancient thinker who first noted it thousands of years ago. It exists because fewer rays emerge at those angles. Less light reaches your eye from that zone, so it appears dimmer. And even in that darkness there is meaning. There is structure. There are even more rare and magical forms, rainbow fragments and glowing halos and arcs that stretch and twist through the mist. But we'll talk more about those later. For now, let's just stay with the primary bow, that glowing arch across the sky, that gentle sweep of colour that feels like a memory, even as you look at it, the kind of thing you could reach for and never quite touch. And that makes sense, because a rainbow has no surface, no substance. You cannot hold it or bottle it or bring it close. You can't walk to its end, because the moment you move, the angles change the droplets, change the light changes, and the rainbow moves with you. Always just ahead, always out of reach. Not because it's playing a trick on you, because it only exists in the act of looking. It is light revealed, not placed. And perhaps that's why it feels so dreamlike, because it belongs to no one and everyone at once. It's the sky's quiet secret shared only when we're willing to turn our back to the sun and look where the light is reflected, not emitted. That thought alone could carry you to sleep, but before you drift off, let's return to the idea of how light moves. Light is a wave, but also a particle, And while that might sound confusing, it's one of the most beautiful complexities in physics. It behaves as both, depending on how you observe it. And tonight we're letting it be a wave, a gentle rhythm moving across space, oscillating in perfect loops, each wave defined by its wavelength and its frequency, which together shape how it bends, how it interacts, and what color we perceive. When we say red has a longer wavelength, we mean it flows in wider, slower ripples about 700 nanometers from peak to peak. Violet, by contrast, is quick and sharp. Only about 400 nanometers, its waves dance faster, tighter, more intricately, and when those waves pass through air and then into water, their speeds change, not equally, but according to their wavelength. Longer waves bend less, shorter waves bend more, and that's the key to the rainbow spread. This is called dispersion, the splitting of light into its component wavelengths by refraction, and it happens any time light passes through a medium with a different refractive index, glass, water. Even diamond, each material slows light down by a different amount and reveals its hidden hues in its own way. But what makes a rainbow so special isn't just dispersion, it's the combination of dispersion with reflection. Inside those millions of airborne droplets, every droplet becomes a miniature prism and mirror in one, refracting and reflecting and refracting again to produce a soft concert of colors. It's strange to think how many droplets are working together in that moment. Billions, perhaps, floating through the atmosphere, each bending light at the perfect angle. Only a tiny fraction send light directly back to your eyes, but that tiny fraction is enough to paint an arc across your field of vision. And the arc is always there waiting, so long as the geometry works and your position aligns. The rainbow appears and disappears, not because it ceases to exist, but because you've moved out of harmony with the angle, like stepping away from the center of a ripple. You can no longer see the shape, only the water again. You might be wondering why rainbows seem to come and go so quickly, and that's partly because of how transient the required conditions are. You need sunlight from behind you, raindrops in front of you, and a relatively clear line of sight in between. If clouds obscure the sun, or if the rain passes, or if you turn your head just slightly, the alignment is broken and the rainbow vanishes. But there's something gentle about that too. The way the sky makes these things available only in moments, never on demand. It's as if the rainbow is an invitation, not an announcement, a suggestion to pause and be present, not a performance on schedule. And then there's the matter of the colors themselves, the way they blend without borders, the soft transitions from red to orange to yellow to green to blue to indigo to violet, and even beyond into wavelengths. We can't see infrared and ultraviolet silent notes in the symphony, just outside our hearing. In reality, there are no clean lines between colors in a rainbow. The divisions we speak of are categories created by our perception. The human eye sees color through cells called cones, which respond to different ranges of light, some more sensitive to red, some to green, and others to blue. The way these cones are stimulated in combination is what produces our perception of color. So when you look at a rainbow, you're seeing your biology at work, interpreting the physical world through neural signals. Your brain reconstructs the smooth gradient of wavelengths into bands, into ROYGBIV, into something that feels familiar. And it's amazing to think that those colors are both real and constructed. They exist as measurable wavelengths, but they're also filtered through your unique biology. And psychology, color is not just physics, it is experience. And in a way, the rainbow is the perfect marriage of those ideas: hard science and soft perception, wavelengths and wonder equations and awe. It reminds us that understanding something doesn't take the magic away. If anything, it adds to it. And that's why we can fall asleep thinking about light and still dream about it too. So let's return for a moment to that image of the sky after a storm. Maybe the rain has just passed and the air is heavy with that familiar scent of petrichor, that earthy sweetness released by wet soil. Maybe there are still drops clinging to the leaves and the street is shining under the low sunlight. Maybe the clouds are just beginning to break apart, parting like curtains on a stage, revealing the soft, warm light of late afternoon. This is the perfect stage for a rainbow. The rain has left behind billions of droplets suspended in the air, and now the sun is casting its light at the exact angle to illuminate them, not directly but indirectly from behind you. That light enters those droplets, reflects within them, and emerges again, forming the arc across your sky. But even as it forms, there's something about it that feels impossible to hold on to. You stare at it, hoping to remember every detail, every subtle shade, and yet it slips through your memory like the rain itself. And perhaps that's what gives the rainbow its emotional weight. Not just its visual beauty, but its evanescence, the way it appears without warning and vanishes without explanation. It becomes a metaphor not just for light, but for time, for change, for fleeting moments of grace. Now, if we shift our focus back to the physics, we find even more elegance hiding in plain sight. The angle of 42 degrees for red light is not random. It's a consequence of how water and light interact, how the speed of light changes depending on the medium, and how that change produces curvature. That precise angle defines the cone of light you see as a rainbow, and the shape of that cone is always centered on the anti-solar point, the spot in the sky exactly opposite the sun. This means that as the sun moves, so does the center of the rainbow, and as the sun gets lower, the arc of the rainbow climbs higher. When the sun is very high, say around noon, the angles don't align, and no rainbow is visible. That's why early mornings and late afternoons are the most likely times to see them. The light has to come from behind you, at a low enough angle to strike the droplets in front of you, and bounce back at just the right elevation. There's something beautiful about that too, the idea that the conditions for wonder are tied not just to physics, but to time, to the hour of the day, to your position in it. And that idea scales even further. The kinds of rainbows seen in polar regions differ from those in the tropics. Because of the sun's angle in the sky, the latitude affects the shape and reach of the arc just as altitude does, as we mentioned before. A full circular rainbow can be seen from high above, from plains or mountain tops, but only ever half that circle from the ground. And of course the intensity of the rainbow depends on the size and uniformity of the raindrops. Larger droplets produce more vivid colours, because they allow better internal reflection, while smaller droplets tend to create paler, softer rainbows, even merging the colours into a near-white glow that fades into mist. There are even rare occasions when tiny raindrops create a phenomenon called a fog bow, sometimes called a white rainbow, or ghost rainbow. It's broader, more diffuse, lacking distinct colours, and often appears in mist or fog instead of rain. And yet it follows the same rules, the same angles, the same invisible mathematics. And if you're very lucky, you might catch sight of more unusual variations too. Supernumerary rainbows, soft pastel fringes just inside the main bow, caused by the wave nature of light interfering with itself like overlapping ripples in a pond. They show that light doesn't just travel in straight lines, it also overlaps and reinforces and cancels itself, creating extra bands of colour that seem to shimmer in and out of view. This is called diffraction, and it adds another layer of complexity to the already intricate dance happening inside those raindrops. Diffraction isn't needed to form the main bow, but when present it reveals the wave behaviour of light in an especially elegant way. It's strange and wonderful to realise that something as seemingly simple as a rainbow is actually the result of so many principles coming together. Refraction, reflection, dispersion, diffraction, geometry, perspective, biology, perception, time and motion, all of it. All of these ingredients combining in a moment that asks nothing of you but your attention. And maybe that's the most remarkable part of all, that something so quiet, so transient, so soft in appearance can carry so much science within it and still remain magical even when we know exactly how it works. Even when we understand the physics down to the angles and the wavelengths and the math, it doesn't take away the beauty. In fact, it only deepens it. Because now when you see a rainbow, you're not just seeing colour in the sky, you're seeing light slowed and curved by water. You're seeing the angles formed between your eyes and the sun, and the droplets. You're seeing a moment of alignment, a fragile geometry that lasts only until the breeze shifts, or the sun moves, or you take a single step forward. And you're seeing yourself too, because the rainbow you witness is not the same rainbow. Anyone else sees it, is personal, precise, and bound to your point of view, your experience, your moment in time. And when you turn your back to the sun and look into the light scattered by the storm, you're part of something that's been happening for as long as rain has fallen, and light has shone long before humans walked the earth, long before eyes evolved to see. Even then, even in the ancient skies, rainbows formed and faded in silence. And here you are now, part of that same continuity, that same optical miracle watching as the rain retreats and the colours bloom. And there's more waiting for us ahead. Of course, we haven't yet talked about moonbows or ice halos or the rainbow's role in art and myth and memory, but those can wait for another night. Tonight, we're simply floating in the wonder of light and water, of bending waves and shimmering droplets, and the soft curve of colour that appears when the storm begins to pass. So if your eyes are heavy now, let them close. If your breath has slowed, let it drift. You've just travelled with a single ray of light from the surface of the sun through millions of miles of space, into the air around you, into a drop of rain, and back again to your eyes, carrying the full spectrum of visible colour. And all of it arranged just right to create one of the most beloved sights in the sky. It's not just a rainbow, it's the universe bending just enough to let you see its secret. And now that you've seen it, you can rest with that gentle knowing inside you. The sky's never empty, the rain is never just rain, and light is never just white. The moment light touches water, everything changes. It's one of those quiet truths in nature, something so familiar you might not think to question it. Sunlight meets a surface and bends as if gently nudged by the substance it enters. The change is subtle but profound, and it's this tiny shift in direction that holds the key to so much beauty. Not just rainbows, but reflections, ripples, glows and glints. And tonight we're going to spend some time with that delicate moment when light slows and swerves, because in that motion is the blueprint of colour. To understand how a rainbow happens, we need to look again at light, not just as brightness or radiance, but as movement and rhythm. Light isn't solid. It doesn't fill a space like fog or dust. It moves. It pulses. It carries energy from one place to another in ripples. So fine and fast they seem like lines, but they're not. They're waves, and within those waves lies something extraordinary. Each colour you've ever seen is just a different speed, a different spacing of these invisible ripples. Long waves make red, short waves make violet, and all the others lie between them, arranged in a gradient so smooth it seems continuous, but is in fact finely structured, each wavelength a number, each number a colour. But light doesn't travel through all things the same way in air. It moves faster in water, slower in glass, even slower. And this difference changes how it behaves at boundaries. When it moves from one medium into another, its path bends a phenomenon we call refraction. And it's this bending that makes a rainbow possible. Imagine millions of droplets suspended in the sky, each one a tiny globe of water, each one capable of capturing a ray of sunlight and splitting it apart inside the droplet. That light bends as it enters, bounces off the far side and bends again as it leaves, and in those two changes of direction the light is broken, not into pieces but into parts, the colours it contained all along. Dispersion is what we call this separation, and it's more than just a spreading, it's a decoding. The original beam of white light is actually a blend of every visible colour, and when the light bends, it doesn't bend uniformly. The longer red wavelengths curve gently, while the shorter violet ones swerve more sharply. This difference causes the colours to spread out into a fan, into a spectrum. And each droplet in the sky sends only a narrow range of that spectrum to your eye, depending on where you're standing, your position. Relative to the sun determines which colours reach you from which droplets. This is why the rainbow forms a perfect arc, because each colour emerges from droplets positioned at a very specific angle. Red from droplets about 42 degrees above the line opposite the sun, violet from droplets about 40 degrees, and so on in between. Now pause for a moment and imagine this geometry playing out across the sky, a vast invisible cone of light centred on the shadow of your head, stretching backward from the sun and forward through the falling rain. Where that cone intersects the curtain of droplets, the rainbow appears. It's not a single thing, but a collaboration between angles, droplets, and time. And because your position is part of the equation, the rainbow is different for every observer. No two people ever see precisely the same rainbow. They see their own version, formed by their own alignment in that precise moment. And this is what makes rainbows so personal. Even as they feel so universal, they are global phenomena, yes, but local experiences shaped by where you are and where you look. Within the primary rainbow there is order precise and layered red curves along the outermost edge, violet along the innermost, and between them lies the full sweep of sunlight, unfurled, every shade arranged by physics, not by intention. And yet it feels intentional, doesn't it? Like a gesture from the sky, gentle and deliberate. And then sometimes just beyond that first arc, a second appears fainter, broader, its colours reversed, violet on the outside, red on the inside. This secondary rainbow is the result of a second internal reflection inside each droplet. The light enters, bends, reflects once, then again before leaving, and in that extra bounce it loses brightness and reverses its colour sequence. Between the primary and secondary arcs lies a region of darker sky known as Alexander's Band, named for the ancient thinker, who first noticed its shadowed silence. It exists because fewer droplets direct light into that zone. Most of the photons are cast either above or below, and so the space between boughs appears dimmer, not because of cloud or shadow, but because of absence. It's a quiet proof that even emptiness has structure, and that light not only reveals but excludes, defines and outlines as much by where it does not go as where it does. Sometimes you might see faint shimmering bands inside the main arc, delicate fringes of pink and green. Especially toward the inner edge, these are called supernumerary rainbows, and they're not caused by refraction alone but by interference. You see, light is a wave, and when waves overlap they can reinforce or cancel each other, creating regions of brighter and darker colour. This is diffraction in motion, and it's only visible when the droplets are small and uniform, as they often are in a mist or light drizzle. These extra rainbows are finer, more delicate, less predictable, but when they appear it's like the sky adding a whisper of lace to an already luminous veil. The geometry continues in other forms too, sometimes when the sun is low and ice crystals are suspended in the atmosphere. You may see arcs that resemble rainbows but are shaped differently. They're halos formed not by spherical droplets, but by hexagonal ice, each shape, each crystal refracting light in its own peculiar way. And this reminds us that the sky's architecture is not fixed. There's no single blueprint for beauty, just a shared language of bending, bouncing, scattering and aligning, and you are a part of it. Not a passive witness, but an active ingredient, because every rainbow only exists when observed. The droplets don't beam colour in all directions. They send each shade along specific lines, and if no one stands in the path, the bow remains invisible, a ghost of potential. This makes the act of seeing a rainbow a kind of alignment, not just of nature, but of attention. The rain, the sun, the angle, and the human gaze all working together to turn a silent equation into a spectacle. And it's not just your eyes involved. Your mind is part of it too, because what we call colour is not simply wavelength, it's interpretation. Your brain compares signals from different types of photoreceptors and assembles a picture full of hue and brightness and feeling. It even fills in gaps, corrects inconsistencies, applies expectations, so that the colours you see are not a raw feed from the retina, but a constructed story, one that feels real and smooth, even if the light that caused it was fragmented or incomplete. So the rainbow becomes not just an optical phenomenon, but a cognitive one, a meeting point between wave physics and visual psychology. Somewhere between the physics and the mind lies the experience itself, that moment when your breath catches just a little, and your thoughts pause when a rainbow arcs across your field of vision. The science behind it might be invisible, but the feeling is not. And it's not just the colours you see, it's the way they're arranged. The softness of the transition. No harsh lines, no abrupt edges, just one hue melting into the next, like light humming to itself in gradients. This continuous flow is called a spectral gradient, and it's the natural outcome of how light disperses through the droplets. And yet if you ask someone to draw a rainbow, they will almost always divide it into stripes, distinct bands, red, orange, yellow, green, blue, indigo, violet, ROYGBIV. A memory trick from childhood science books a way to remember the order, but not necessarily the reality, because the real rainbow has no such divisions. It's smooth, fluid, uninterrupted. So where do those bands come from? The answer lies not in the sky, but in the eye and in the brain's tendency to categorize, to label, to create boundaries where none exist. The human visual system enhances contrast. It sharpens transitions. It turns a slow gradient into stepped perception, so that we think we're seeing lines when we're actually seeing slopes. It's not a flaw, it's a feature one that helps us navigate a world full of textures and shapes and subtle shadows. but it does mean that our experience of the rainbow is shaped not only by nature, but by our neurology. And the colours we name are only a small part of what's really there, because the rainbow doesn't end with violet and it doesn't start with red. Beyond the edges lie wavelengths we cannot see. Infrared too long to trigger our photoreceptors and ultraviolet too short to register, but both present, both real part of the same spectral continuum. Some animals can see them. Bees, for instance, can detect ultraviolet patterns on flowers that we are blind to snakes sense infrared heat from prey. At night, birds use hidden colours in their feathers to communicate what we think of as visible light is only a narrow slice of what light can be. And this too adds to the rainbow's mystery, because we know that even in the moment of full perception, we're only ever seeing part of the truth, and yet what a beautiful part it is when you stand before a rainbow. You're standing in the path of light that has travelled millions of miles from the surface of the sun into the sky, bounced through the atmosphere, touched a droplet of rain, and been bent toward you alone. And in that moment all the invisible becomes visible, light becomes colour, geometry becomes art, and time seems to stretch. You don't have to understand any of this to feel it. But when you do understand it, when you start to sense the precision and the physics and the biology interwoven like threads in a tapestry, it doesn't take the magic away, it deepens it. It's not just beautiful, it's astonishingly exact. There's a certain comfort in knowing that something so delicate is also so dependable, that even the most ethereal sight in the sky is grounded in laws that do not fail. The angle of red light in a rainbow is always the same. The curve it forms always arcs around your shadow, and the conditions required to create it are always precise. Light must enter a droplet at just the right inclination, reflect inside with just enough energy to bounce, and then exit at an angle that meets your eye every step, predictable, every step repeatable. And yet the result is never the same, and no two rainbows are identical. Even if their physics are because the sky is never the same, no two raindrops follow the same exact path. No two observers stand in the same place or gaze with the same perspective. It's like a symphony that plays by the same score, but never the same emotion, never the same moment twice. And then there's the symmetry. A rainbow isn't just curved, it's perfectly symmetrical around that invisible point opposite the sun. If you were high enough, you could see the full circle of it surrounding the shadow of your own head on the clouds below. Pilots sometimes do passengers with window seats and patient eyes see it hover like a ghost ring. And around that ring more might form under the right conditions, reflected rainbows echoed from the surface of water, or even multiple concentric bows wrapping outward with diminishing brightness, equal elegance. It reminds us that what we usually see is only a slice of something fuller. We catch the arc, not the circle. We see the colours, but not the continuum. We trace the visible, but sense the hidden. And this awareness that there is more than meets the eye is not just poetic, it's scientific too. Because rainbows also carry information. They reveal the size of the droplets in the rain. Smaller droplets make softer rainbows wider with less defined edges. Larger droplets produce sharper, more vivid bows with intense saturation. The nature of the light source matters too. Sunlight at low angles produces long dramatic rainbows, while midday light often fails to align. But all the atmosphere itself influences what we see. Dust, haze, humidity all play roles in scattering light and shaping what reaches us. In this way, the rainbow becomes a kind of weather report, not just in colour, but in character, a silent reading of the sky's condition. And still, despite all this analysis, there's something in the rainbow that defies reduction, something you feel before you think about it, a sense of hush, a pause like the world has inhaled. Maybe that's why so many cultures see the rainbow as a sign, a bridge, a blessing, something between realms, something not quite of this world. We've built instruments that can measure the angle of light to the 10th decimal spectrometers, that read the exact frequency of every wavelength and satellites, that map clouds and sun positions. In real time, we can predict the likelihood of rainbows, even simulate their formation in laboratories. And yet when one appears in the real sky above your real world, it never feels manufactured. It never feels mechanical. It feels like something whispered to you, something secret, even when others see it too. And maybe that's because it arrives only in transition in the moment after the storm, not during the violence, but in its retreat. As the light returns and the rain softens and the world exhales, the rainbow is never part of the storm, it is part of the healing. And that symbolism is not just cultural, it is felt. It's built into our relationship with the world around us. The rainbow shows up when tension breaks, when the contrast between light and water is at its peak. When clarity returns, it is the visual equivalent of calm after chaos. And like all forms of light, it's fleeting. You can't trap a rainception itself for the way we meet the world and make meaning from it, for the way we stand in the path of light and let ourselves see. Because the rainbow does not shine out like a spotlight, it does not demand to be seen. It only becomes visible if you turn and face it with the sun behind you and the rain before you. There is a quiet humility in that, and perhaps that's why it feels like a gift. Not given freely, but offered, gently revealed only when we slow down enough to notice the angle, when we're not looking directly at the source of light, but instead at how it is reflected and refracted around us. And that idea stays with you long after the colours fade, long after the clouds move on, long after you've turned away and gone inside. The memory of the rainbow lingers, because it didn't just appear in the sky, it appeared in you. A brief alignment of elements and awareness, a meeting of science and softness, and just like that it was gone. And still it remains. Inside every raindrop there's a secret, a place where light enters, bends and bends again, and while it might seem like such a tiny thing, the shape of that drop matters more than you might think. Its curve, its smoothness, its symmetry. These are what allow it to become a prism, a lens and a mirror all at once. And yet the droplet is not a perfect sphere. It flattens slightly as it falls, pushed by the resistance of the air, distorted by the motion of its descent. Large raindrops are shaped like hamburger buns rounded on top, flatter on the bottom. Smaller ones keep closer to spherical, but they too wobble as they fall. Even so, they are round enough and clear enough to perform their quiet miracle. When sunlight enters a droplet, it refracts, bending as it slows from air into water. The exact amount of bending depends on the angle of entry and the wavelength of the light. Then it reflects off the inside surface of the drop, bouncing once and heading back toward the outer edge where it refracts again as it exits, bending one more time back into the air and on toward your eye. This double refraction with a single internal reflection is what creates the primary rainbow, the one we see most often. But if we follow the light more closely, the path becomes surprisingly complex. Photons do not always follow a single neat trajectory. Depending on the angle of entry, some light passes straight through the droplet, never reflecting at all. Others may reflect twice or more, bouncing around the inner surface before finally escaping or being absorbed. The rainbow we see is the result of the most efficient and concentrated path, the one that directs the maximum amount of light toward the viewer at around 42 degrees for red. But that number 42, it's not just a number, it's a peak, a maximum in what's called the deviation curve, a plot of how much light bends inside the droplet at various angles and wavelengths. It turns out that at this specific angle, a large concentration of the light exits in nearly the same direction, creating a bright focused beam. This is what makes the rainbow appear as a distinct arc rather than a blurry smudge of scattered colour. It's a peak of light density, a focused caress of photons. And this explains why the rainbow has such sharpness, why the colours seem to organise themselves into a clean curved edge. Light that exits the droplet at other angles is less concentrated, less organised, less visible. It's still there, but not aligned in a way that reaches your eye with clarity. Now imagine this happening across millions of droplets falling through the air, each one performing this same optical ballet, not in isolation but in harmony. The droplets you see are just the ones in the right place at the right moment to send their light along the exact line required to enter your eyes from the correct angle. Others are doing the same for someone standing next to you or far away. Every person sees a different rainbow, not because the droplets are different, but because the viewing angle is that detail changes everything. The rainbow isn't painted on the sky, it's constructed from light and position, and you are part of that construction. Your shadow, your stance, the turn of your head, all of it determines which photons reach you and which ones pass silently by. Some droplets enhance the rainbow, others dim it. The size of the droplets matters more than most realize because the size changes the sharpness of the colors and the brightness of the bow. Larger droplets create more vivid rainbows. Their greater internal surface area allows for a stronger reflection and a clearer separation of light. the colours appear bolder, more saturated, sharper. Smaller droplets scatter, light more diffusely. Their rainbows are paler, more blended, their edges soft and dreamy, sometimes almost white at the edges as if the colour has sighed and settled into mist. This is why a rainbow seen in a fine drizzle might look ghost-like, almost transparent, while one formed in heavy summer rain can blaze across the sky like a banner of liquid fire. And it's not just brightness that changes the width of the rainbow is affected too. Smaller droplets make broader bands where the colours stretch and blur. Large droplets produce narrower bands that slice cleanly across the sky, each colour hugging the next in quiet order. And sometimes when the droplets are just the right size and the sunlight hits just right, an extra phenomenon appears: supernumerary bows. These faint repeating bands sit just inside the main rainbow, usually near the violet edge, soft pinks and greens, like echoes of the main spectrum. They're not formed by simple reflection or refraction, but by interference. Because light is not only a ray, it's a wave, and when waves pass through narrow slits or around edges, they overlap and interfere with each other. They can cancel out or reinforce, creating patterns of light and dark, bright and dim. And when these waves emerge from the droplets, they sometimes do so in just such a way that interference patterns become visible. The result is like a ripple within a ripple, extra rainbows curled beneath the first ones, fine and subtle, rarely noticed unless you're still, unless you're looking slowly, and they are not guaranteed. They require uniform droplets of very specific size and a precise angle of sunlight. Too much variation in the droplet size, and the patterns fade into invisibility. Too little moisture, and there's nothing to reflect at all. But when the conditions align, the sky adds embroidery to its tapestry, an extra thread of light weaving delicately inside the main arc. It's worth noting that these effects are not illusions. They're not tricks of the eye. They're the result of real physical processes, but ones that only become visible when enough variables fall into harmony. And that's the nature of a rainbow. It isn't a constant thing. It's an emergent one, a phenomenon that only shows itself when the world reaches a certain balance. Sun and water angle and distance, order and timing, you could try to chase one and never quite catch it. Not because it's elusive, but because it doesn't exist in one place. It exists in relation to you. And while you gaze at the colours stretched across the sky, what you're seeing is only part of the spectrum. The rainbow feels complete to us, but it's not full. Not truly. It begins in red and ends in violet, but light extends far beyond both ends into frequencies we cannot see below. Red is infrared, a realm of long, gentle waves full of heat and whisper. Quiet energy beyond violet lies. Ultraviolet waves, tighter, faster, more energetic. They dance just outside our visual range. Some creatures can see these hidden colours. Bees, for example, can detect ultraviolet markings on flowers, signals we will never notice. Snakes sense heat as infrared, glowing outlines of warm-blooded prey in the darkness. We humans are tuned to a narrow band of wavelengths enough to paint our world in vivid detail, but not so wide as to overwhelm, and the rainbow is a reminder of that limit, a visible slice of a larger unseen whole. So when we look at a rainbow, we're seeing not all the light, but only the part we're equipped to translate. And even then, no two people see it. Quite the same eyes vary slightly in their sensitivity, in the distribution of cones and rods, in their ability to distinguish subtle shifts in hue. Age plays a role too. Children often see more intense violets than adults, who may begin to lose sensitivity to the shortest wavelengths over time. And then there's the brain. Our interpretation of colour is not just biological, it's cultural, emotional, contextual. Two people standing side by side, seeing the same physics, may report slightly different colours because of how their minds process the input. Colour is not just wavelength, it is perception. And so the rainbow you see really is yours, formed by light, sure, shaped by geometry, absolutely, but completed by you, by your vision, your position, your presence. There's something quietly profound about that nature offers a universal pattern that resolves differently for everyone. It makes the rainbow feel not just like a spectacle, but a moment of participation. Like you're not just observing light, you're resolving it. You are the final lens, the last curve in the path of its journey. And that's true, not just for colour, but for meaning. The rainbow is never just about optics. It's about where you are when the conditions come together. It's about how the elements align without your invitation or intention. Light bends because that's what light does. Rain falls because gravity pulls it from cloud to earth. But the rainbow only appears if you're there to complete the triangle. It's not a painting in the sky. It's a conversation, a relationship between what is happening and where you're standing. And that truth feels intimate. The angles don't just govern the physics, they decide who gets to see it. If you're a few feet to the left or right, your rainbow changes because different droplets are responsible for sending their light your way. The rainbow you're seeing is yours alone. Even if someone stands next to you pointing at the same spot, you're both experiencing different arcs, assembled from different photons scattered through different droplets. It's a reminder that no view is truly shared, not completely, and that makes the experience more precious. It means that you're always in the center of your own rainbow, always standing at the heart of your own spectral wheel, with the sun behind you and the sky opened ahead. What a quiet power that is to realize that the most beautiful thing the sky can offer is shaped not just by clouds and sun, but by you. When the sun is low and the rain is light and the sky opens just enough, there is a window, a moment when everything aligns and the rainbow appears, not summoned, not forced, but revealed. And that revelation is never loud. It doesn't crash or flash. It emerges like breath, like memory, like something you knew as a child, but had forgotten the arc is there, curving across the sky, perfectly symmetrical, centered not around a landmark or a cloud, but around you. And in that stillness you might begin to feel what the rainbow really is, not just light or water or geometry, but time and attention, a message painted in photons that began their journey at the heart of the sun, travelled across the void of space, filtered through the atmosphere, and finally touched a droplet of rain at just the right angle to turn back toward your eye. That is the scale of what you're seeing, a story written in sunlight shaped by the sky, but only completed by your gaze. And even though the rainbow will fade, even though the clouds will shift and the sun will move, the knowing will stay, the quiet awe. The hush of seeing something both ancient and immediate will settle into you, like light into water. And that is why we remember rainbows not just for their colour, but for their calm, not just for what they show, but for how they make us feel, like we are standing in the exact place the universe meant for us to be, even if just for a moment. Every rainbow begins not in the rain, but in the sun. The light that makes it is ancient in motion, young in arrival and relentless in rhythm, pouring across the solar system at nearly 300,000 kilometers per second. It's not the heat of the sun that builds the rainbow, but it's light that appears white, but is not white at all, just balanced and blended so seamlessly that no one colour shouts above the rest. It is only when that balance is broken, when the beam slows and bends, that we glimpse the hidden architecture within, and this sunlight doesn't arrive evenly. The earth being curved and tilted receives it at different angles, at different places and times. The equator bathes in direct light. The poles glance it from the side, the morning stretches shadows long and gold, the evening folds the sky into firelight, and the angle of that sunlight is everything to a rainbow, because the bow only forms when the light is behind you and the rain is in front of you, and the geometry of your gaze meets the angle of exit from the droplet. And for that to happen, the sun must sit low enough that the light can strike the falling water at the correct inclination around 40 to 42 degrees, and this is why we do not see rainbows at noon. The angles will not cooperate, but as the sun leans into the late day, or emerges early from the horizon, its beams become oblique, and the sky becomes potential, not yet a rainbow, but the conditions that allow one. And this matters because it shows us that the rainbow is not just an object to be observed, but a process in motion, a moment between weather and light that requires the right timing, the right view, the right relationship between you and the sky. And that makes it not just rare but relational, not something placed but something offered. And in that offering is a kind of trust between nature and awareness, the world saying, here, if you're still enough, you'll see. The air between you and the rainbow isn't empty. It's alive, filled with currents, temperature gradients, tiny particles, and shifting layers of moisture. It is the stage upon which light performs, and even though we don't see the air itself, we feel its fingerprints in the way the rainbow forms and fades. Every change in humidity, every breeze, every rising or falling thermal can tilt the balance enough to sharpen or dull the bow, And what you're watching when the rainbow appears is not just the bending of light, it's the invisible choreography of atmosphere in motion. All of it shaped by a greater force, the sun's energy streaming in, warming the ground unevenly, heating oceans and plains and rooftops at different rates, creating pockets of rising warm air and sinking cool air, a convection system on a planetary scale. And this uneven heating drives the weather. It pulls clouds into formation, lifts water into the sky, drops it again as rain or snow or mist. And in the midst of all that movement, sometimes everything aligns just right, for light to trace its arc across falling droplets. The rainbow isn't static. It shimmers, it flickers, it breathes slightly in and out with the air that surrounds it. And if you pay close attention, you'll notice how quickly it can change, how a gust of wind or a break in the clouds can strengthen or soften it, how its edges sometimes blur as if painted in watercolor and then snap back into definition. It is never quite still because the sky is never still, and that makes every rainbow a moving portrait, not just of light, but of the invisible world that carries it. Beneath the science behind a rainbow lies something even deeper, a truth about how the universe favors balance and seeks it constantly. Even in chaos, the rainbow is a product of imbalance and correction. Light arriving in a straight beam encounters curvature in droplets and bends its path. The sun heating the earth unevenly causes air to rise and fall. Rain forms as moisture condenses, then falls to even the scales again, and in the brief intersection of these forces something beautiful emerges. The rainbow is not just a consequence of optics, it is the sky trying to smooth itself out. It is energy redistributing. It is light navigating disorder, and in doing so becoming something that stuns us into silence. And this process doesn't require a viewer, it would happen with or without our presence. But it only becomes a rainbow when it's seen. It only transforms into meaning when a mind receives it and names it, and allows it to stir emotion. So in that sense, the rainbow is both an accident and a collaboration, an event triggered by physics, but completed by perception. And this tension between chaos and order, between chance and precision, between wild atmosphere and narrow geometry, is what gives the rainbow its unique emotional power. It is a glimpse of symmetry in a turbulent sky, a flash of harmony, where moments ago there was only motion. And even though we know how it works, even though we can trace every photon and calculate every angle, the all remains untouched. The rainbow is proof that beauty doesn't disappear when explained, it deepens. There is something humbling about standing beneath a rainbow, something that pulls your gaze upward and quiets the noise inside your thoughts, because no matter how tall the buildings or how fast the world moves, the rainbow arches over it all untouched by urgency, existing on its own terms, bending not to time but to light. It reminds you that some things cannot be bought or built or held. They can only be noticed, and noticing is a form of reverence in a time when attention is currency. To give your attention freely to something so fleeting as an act of quiet devotion. It's you saying yes to beauty without demand or distraction. It's you agreeing to be still for long enough to let light speak its shape into your awareness. And perhaps that's why we don't just see rainbows, we remember them. We carry them with us, not just as colours, but as a feeling, a softness, a moment when the world felt more connected, more meaningful and somehow more kind, because in that curve of light is a story about contrast, about sun and rain, about motion and stillness, about things that should not coexist but do. And from that unlikely union something luminous emerges, not in spite of the tension, but because of it. And that's the lesson tucked inside every bow you've ever seen, that wonder does not need to be permanent to be real, and that fleeting things can still be deeply true. What the rainbow ultimately offers is not just light or science or colour, but permission. Permission to pause, to marvel, to remember that even in the middle of storms the sky has the capacity for grace. It gives you that moment without asking anything in return, without requiring a reason or occasion. It simply arrives, bends into shape, stretches its quiet arc across the sky, and then fades as gently as it came. And in that gentle fading there is a kind of wisdom, a reminder that beauty doesn't need to last a matter, and that presence even brief is powerful. The rainbow does not stay, it does not wait, but for the time it is visible, it is complete, and perhaps that is its greatest gift. Not the spectacle, but the softness, not the rarity, but the readiness to appear whenever the world holds just enough contrast to allow it to form, and when it does, it forms entirely, and then disappears entirely like a whisper that speaks once and never needs to be repeated. And still, we remember, we wait for the next one. We search the sky after rain. We angle our gaze when the clouds begin to break, because we know that some truths do not need to be spoken loudly to be believed. They only need to be seen, even if only for a moment, in colour curved across the sky. Not all rainbows arrive in sunlight. Sometimes the sky offers them in shadow and silence. In the glow of the moon, these are called moonbows, and though they are formed by the same rules of physics, they feel different, softer, quieter, as if the sky is whispering instead of singing. The light from the moon is only reflected sunlight, but it arrives dimmer, less forceful, and so the bow it creates is often pale, sometimes even colourless to the human eye, appearing instead as a silvery arc in the darkness. But if the night is clear and the rain gentle and the moon full and bright enough, the colours do emerge faint like dreams, like memories barely held, and just like their daytime cousins, these moonbows depend on angle and alignment. The moon must be low, the rain must be opposite, and you must be standing in the centre of the invisible circle, with your back to the glow, and your eyes tuned to the hush of light, refracted through the night. And when all of these things agree, the moonbow appears not in thunder or brilliance, but in stillness, and for a moment the sky feels deeper than usual, as if it is showing you a version of itself that only comes out after dark. And this too is part of the rainbow's truth, that it is not limited to one time or one kind of light. It is an expression of alignment wherever light meets water, and where a watcher stands ready to receive. And it reminds us that beauty can arrive even in the shadows, not in defiance of darkness, but drawn gently through it. There are rainbows that touch the ground or seem to hover just above it, not in the clouds or high in the sky, but near rivers or fountains or the spray from a garden hose. These close rainbows follow the same rules as the grand ones above, but because the droplets are near, and the source of light more controlled, they feel more intimate, more immediate, like magic unfolding at your feet. The mist becomes a canvas, and the sun, your brush, tilt the hose just right, and the arc appears, step into it, and it dissolves, because again it is never in one place. It is always in the angle. And that realization invites play, invites curiosity, invites movement through light rather than around it. And in the same way that a droplet falling from the sky can hold a spectrum, so too can a droplet from your fingertips. The laws do not change only the scale, and in that shift something becomes clear. The rainbow is not rare in potential, it is only rare in patience. The physics are always waiting, always ready to reveal colour whenever light and water and vision agree. And all we need to do is notice, to pause long enough, to see the alignment waiting quietly in ordinary things, because a garden hose is not just a tool, it is a prism, a key, a small bright window into the rules that guide the world. And when we treat it that way, when we tilt it into the sun and let the spray rise and fall, we're not just watering the earth, we're painting light into arcs. Some rainbows aren't made of rain at all. They form in the shimmer of waterfalls in the mist that rises from crashing waves in the steam of geysers, or even the icy halo of snow machines carving arcs through cold air. The source doesn't matter. So long as the droplets are present and suspended, and the light has room to enter, bend and return, what matters is the condition, the quiet cooperation between chaos and clarity, between turbulence and structure, where water scatters into droplets just small and uniform enough to play host to light's performance. These places teach us that a rainbow is not tied to the sky, but to the shape of moisture, to the scatter of droplets, and the stillness of the observer standing in the path. And it means that the bow is not always far away, not always above. Sometimes it appears around your shadow at your feet or over your shoulder, sometimes even in reverse on the surface of a lake reflecting upward, as if the world were doubling its offering. And this reversal isn't illusion, it's symmetry. The rainbow exists in a circle. Always. We simply see the part allowed by horizon and perspective, and when water lies still and skies clear enough, it shows us the rest, a glimpse of the full geometry. And in that glimpse something settles in you, the knowledge that the rainbow is whole, even when you can only see a part of it, and that perhaps so are you. Not all bows are bright. Not all colours demand to be seen. Sometimes the rainbow takes on a ghost-like form, soft and white, and nearly invisible. This is the fogbow, born not from rain but from mist. Its droplets are far smaller, and because of that the light does not separate into vivid stripes, but merges into a pale arc, a halo of whiteness that floats in the grey. It is harder to find, easier to miss, but just as real, just as precise in its geometry, and when it appears it feels like a secret, like the sky is whispering only to you because it does not announce itself like other rainbows. It waits gently in the fog for a viewer to slow down to look closely. And this too is part of the spectrum, the unseen, the subtle, the delicate version of the phenomenon that reminds us that not all beauty is bold, that some of it arrives quietly dressed in pale light and soft edges, and it's still governed by the same angles, still shaped by refraction and reflection, still drawn by sunlight passing through droplets, but its voice is lower, its presence more like breath than brightness, and when you see it, it stays with you. Not because it dazzled, but because it revealed the kind of wonder that hides until the world grows still. Rainbows remind us that light does not belong to one time of day or one kind of storm. They exist wherever moisture floats and light finds it, and we are willing to look. Sometimes that means sunlight after rain, but sometimes it means headlights shining through mist or the glint of light on sea spray at sunset, or even the subtle prism on your window pane as morning spills into the room. And what all of these have in common is the idea that beauty emerges from interaction, from alignment, from the invisible moment when everything simply fits. And maybe that's why the rainbow speaks to us across centuries and cultures, because it does not need translation. It does not need words or permission. It simply appears when light and water and wonder meet. And even though we can explain every part of its formation, trace the bending of rays, the bouncing within droplets, the spread of colours by wavelength, none of that knowledge dulls the effect. If anything, it sharpens it. It deepens our gratitude that the world is made this way, that the same laws that govern the stars and tides can also produce something so quietly magnificent, and place it not in space or theory, but directly into our field of vision. A reminder not just of physics, but of presence, that when the conditions are right and we choose to notice, even the smallest droplet can hold a universe of colour. Every rainbow is a question answered in light. It begins with imbalance, with scattered sunlight and suspended water, and ends with perfect geometry delivered to the eye of a watcher. The arc itself is evidence that nature is always trying to even things out, to stretch heat from warm to cold, lift moisture from sea to sky, and return it again, and the rainbow appears not as an endpoint but as a side effect, a beautiful consequence of that constant attempt to balance. And when we look at it, what we're really seeing is not just light split into colour, but a moment of resolution when all the motion and swirling and falling align into something clear and still and curved, and in that shape is stability, drawn from movement, a reminder that even the most dynamic systems sometimes pause to reveal the structure hidden within them. And we need those pauses. We need them to understand the rhythm of the world around us and the one within us, because everything we are is shaped by rhythm, breath, heartbeat, thought, emotion. Even our vision operates in cycles, in pulses of signal, sent and received. So it makes sense that we're drawn to a shape made by light, moving in rhythm through the sky, a circle wrapped in colour, a spectrum arcing over the horizon, not to mark the end of the storm but to mark the balance after it, a visual exhale from the atmosphere itself. Somewhere deep in the physics of the rainbow lies a truth that reaches far beyond weather, beyond colour, beyond science itself. It's the truth that even the most fleeting things can carry structure. Even the most chaotic systems can momentarily align into something precise and graceful, and that alignment doesn't require permanence to be meaningful. The rainbow doesn't stay. It doesn't need to. Its beauty is in its arrival and in its departure, in the way it teaches us to look quickly, to look carefully, to meet wonder on its own terms. It asks nothing of us but attention, and yet it leaves something behind, something we carry long after the colours fade, a feeling that the world is still capable of gentleness, that even in storms there is structure, that after disorder something luminous may emerge, and that feeling is not accidental. It is the echo of the math and light and water that built the bow. It's what happens when science becomes sensation, when the rules of the universe pass through the lens of perception and land as emotion. And maybe that's what rainbows really are, not just arcs in the sky, but bridges between the measurable and the felt, the visible and the remembered, the world as it is and the way we experience it briefly in colour. To understand a rainbow fully is to walk along the edge where logic meets longing, because no matter how precise the angles, how exact the equations, how beautifully predictable the physics, there remains something in the bow that resists total explanation. Maybe it's because it doesn't belong to us. It belongs to the sky, and we only ever borrow it for a moment. And in that borrowing we are reminded of what it means to witness, not to control, not to possess, but simply to be there when something extraordinary happens and to be changed by it, even if only slightly. And maybe that's why we chase rainbows even when we know we can't catch them, because part of us hopes that by moving closer, we'll not only see more of the bow, but more of ourselves reflected in it. Not in the literal sense, but in the way we respond to it, in the quiet awe, in the breath we hold, in the way we reach for our camera and then pause. Realizing that a photograph can't hold what we feel in the hush that follows that pause, we're reminded that wonder doesn't live in explanation. It lives in presence. And the rainbow is a teacher of that presence again and again. We live surrounded by light, yet we rarely see it for what it truly is. We take for granted its constant arrival, its silent presence, warming surfaces, illuminating faces, sliding through windows, spilling across our rooms, and yet it is only when that light is interrupted, when it meets the curve of a droplet, or the edge of a cloud, or the mist of an afternoon rain, that it reveals its hidden complexity, and reminds us what it's made of. A rainbow is not new light. It's the same light we see every day, simply redirected, restructured, made visible in a different way. And this teaches us that sometimes clarity doesn't come from adding more, but from shifting the angle, changing how we look, or how we let something pass through us. Maybe the world around us is full of unrecognized beauty, waiting for just the right alignment to emerge, and maybe we're the droplets. Maybe we're the medium through which that beauty is refracted, bent, reshaped into something others can see. And that isn't just poetic, it's practical. It's an invitation to carry the physics of the rainbow into the way we live, to remember that what seems ordinary might simply be undiscovered, and that under the right conditions it too could glow when the rainbow fades and the sky returns to grey or blue or gold. It leaves behind more than memory. It leaves behind awareness, kind that makes you look a little longer. The next time it rains, or tilt your head slightly when light strikes glass or water. It plants a quiet knowing that beauty is always near, not because it's constant, but because it's possible, and that possibility is enough. It's enough to remind us that the world is governed not only by laws, but by patterns, and those patterns don't just dictate movement and energy. They create moments like this where all the variables come together, not for utility, but for wonder. A rainbow has no function, no purpose in the way we usually measure things, and yet it arrives across time and culture as a symbol of connection, of transformation, of calm after the storm. Maybe that's because it reflects something true about us too, that we are shaped by contrast, that we become visible, not in spite of our complexity, but because of it, that what bends us can also reveal us, and that within every one of us is the potential to refract what we carry into something that casts colour back into the world.